In the first question, we have a ball of mass m suspended from two strings of unequal length as shown above in the sketch. The magnitudes of the tensions T1 and T2 in the strings must satisfy which of the following relationships. So it's important to kind of in your head set up this kind of free body diagram, if you will. There's the ball, and then there's two separate tension cables that are not tensions in each of the cables that are not equal to each other. One of the tensions has a ty component going up, and I'm going to call that one ty subscript 2 to kind of stay with the same naming convention. And the x component of T2, which we'll call tx2, is going to the right. And if I were to kind of take another look at T1y, the y component is going to be smaller. I'm going to talk about this in just a little bit. So ty1 is to the left, is up, and tx1 is to the left. It has to be the same size as tx2. So tx1 and tx2 have to be the same size because we know the ball is not moving. The sum of the forces in the x direction is equal to 0. There are no other forces in the x direction. We know that on the free body diagram, if we were to sketch in the last force, there would be a weight force, which we can label as mg. In the y direction, we also know that the sum of the forces is equal to 0, and that's because the ball isn't moving. So we can say then that ty1 plus ty2 must be equal to 0. Now, there's a couple of different ways to look at this. Since the x components are equal to each other and the angles are different, then the y components have to be different. And I think that's one way of looking at this problem. So if I were to sketch in blue the triangle on the right, we have an x component that looks like this. The y component has to be larger because the actual sum of tx2 and ty2, which we'll call the actual vector t2, has to be the sum of those, right? So I have this right triangle, tx2 plus ty2 is equal to t2. And it has to be more vertical than t1. If I were to do the same thing on the left-hand side, the base of the triangle that I'm going to draw for T1, so I'll call that TX1, has to be the same size as TX2. We've talked about that, but the angle is much smaller. And so since that final T1 is going up along that kind of smaller angle cable, then TY1 has to be smaller than TY2. That also explains that when we do the vector addition, YT2 is going to be a bigger number than T1. So what we're not saying is that in our dynamics equation, by the way, I think I made a mistake here. I forgot to include the weight. Ty1 plus ty2 minus mg is equal to 0. That's my mistake there. So let me zoom back out because I think I make that mistake again. Okay, so ty1 plus ty2 minus mg is equal to 0. And so what we're saying is that ty1 plus ty2 is equal to mg when I add it to kind of both sides. So choice D cannot be the correct answer. That's saying that the actual magnitudes of the tension in the cables, T1 plus T2, not the components. E is incorrect because it's saying T1 minus T2 equals mg. That's an incorrectly written dynamics equation. But we can see that T1 has to be less than T2. That is true because of the angles in those cables. They are not equal to each other, which is why A and B are incorrect. And so let's take a look and call that final answer for question number 1 C.